Assalamualaikum. My name is Muhammad Firdaus Afiq bin Asman, and I'm going to present my final year project proposal. Its title is The Development of a Fire Precaution Management System. What is fire precaution? The term fire precaution refers to any measure to minimize the risk of damage from fire to life or property. Project summary. Fire precaution is a plan to overcome fire damage to buildings. In general, fire precaution management is the enforcement of laws, equipment installation, ethical and safety plan. This legislation is compiled officially to be core of fire safety. However, the laws often comes in the form of long file or books. The laws were derived directly from Universal Building Bylaws 1984. The system was designed by Microsoft Excel and the result is shown within the Excel respectively. The user will insert input data into the Excel such as array of parameter, and the Excel's written algorithm will display the results such as types of extinguished system or volume of water storage. This will help engineers save time from referring a long UBBL list of laws. Literature review. This is the UBBL handbook, and this is from other resources that I make some research. The management system can be the fire safety management strategy, evacuation procedures, fire and smoke control system, firefighting strategy, fire protection strategy. This is the consequences of abandoning fire precaution management system. A fire accident has been occurred on Sultanah Aminah Hospital and 6 mortality cases were reported on that day. This hospital has been reported to be operated without safety building certification over years. As stated, the goal of fire precaution is to contain and cope fire accidents. To achieve this goal efficiently, an easy-to-use system is required. Henceforth, creating a semi-automatic system or software that has the information from UBBL, but it was simplified and has calculations algorithms embedded within the software to help engineers design fire precaution system much faster rather than checking UBBL only. Problem statement. The problem rises as when engineers design a building, they need to refer the laws compiled in UBBL. However, the UBBL itself is a long manual book to read. Reading UBBL book is a tedious work. Engineers have a lot of project deadline to rush. Objective: to construct a simple algorithm and calculation for physical values such as water storage in liter. To construct a fire precaution management system according to UBBL 1984 as simplistic as possible. The scope of this project is the fire management system is within the UBBL 1984 only. The system that I created would not offer any building redesign. It only gives out appropriate fire precaution management system. As for methodology, this is the flowchart of the project. This is the start of the project. It's problem identification, data collection and brainstorming process, and this is the decision making process, which is selecting a software. If the software is not suitable, we back to this process. If it's suitable, we continue to the next process. The next process is design a system that manages searchable data. The next is data input. The next process is simulation decision making. If it succeeds, it's comes to an end. If it fails, we need to reevaluate the system. Data collection. Data and loss has been stated and compiled into UBBL. Analyze the data and construct a system that act and compute the fire precaution installment required. So data we get from this book, and this is the example of the data that I use. Designing the system. First, we have to create tables such like this, and interface that looks like this. Next, to set up the cells in here, we need to press data validation inside the data tools. Next, set up a coding by pressing Ctrl and F11 simultaneously. The coding must be exactly like this. After that, the system is ready to use. For sum table, we do not need such coding. We only need to apply formula into the cell. For example, this cell, I have to put formula written like this. This is an example of mathematical statement formula. Expected result. This is the preliminary result. We have a file here, undergo the name temp schedule. Inside the file, there's so many types of buildings, and let's try to pick one. The yellow box is the user interface. The user is required to input the types of building. For instance, we choose library over here, or you can type library here, or you can copy and paste library into here, and then in the field section, press types. When this has been done, press search to run the program. The result will be shown here in table form. This is the result for extinguishing system. This is for fire alarm system, and this is emergency lighting. The result will be shown as their respective code. For example, G means hose reel, and A means signal point units. This code is used in the UBBL. It's not created by me. For next table,
we will see the calculation of water storage capacity. For there's a three types of table here. The minimum quantity of water required for hose reel, for hose reel system, fire hydrants, and so on, depending on the title that we need. So what we have to do here is to put the input for floor area of the largest floor in square meter area. Let's say we put 240. Press enter, and the water storage required in liter will be shown here at 18,200 liters. Let's put another number such as 501. Sorry, Mak. Or 601. Press enter, and the liters here will show 27,300. Let's try 937, for instance. Press enter, and the result will be shown. This is the minimum quantity of water storage for host field system. This particular table requires you to put 1 digit because this is the number of host field. There's a result for each number, 2, 3, and so on, until 6. 6 is the maximum host field recommended. If we put more than 6, let's say 9 or 8, it will say too many host fields. For this table, in principle, we put 400, the answer will be shown here. Let's say 1333. The answer will be shown in this.
Okay, that's the example for water storage required. And that's it for my presentation. Thank you for listening.